This time, we will have to solve the integral of the given expression, the integral of your x dx plus y dy along your path c. But this time, your path c is a parabolic curve, y is equal to x squared from 0, 0, and 1, and 1. This is a parabolic curve, so we're going to use here the parameter or the parameterization of our x and y components. Take note, this is equivalent to the integral of your p of xy dx plus q of xy dy along your path c. This would mean clearly your p of xy is just x, we don't have the y component, and your q of xy is just y, we don't have the x component. It would be easier for us to look at it because we are just going to use x of t for x and y of t for our y. By the way, this is the complete form of the process. You have here p of x of t and y of t times the first derivative of x of t plus q of x of t, y of t times the first derivative of y of t dt from a to b. So what we need to do here is to identify the x of t and its first derivative, y of t and its first derivative, together with a and b values so that we can actually solve for the real line integral. Now, for our a and b, it's clear that from 0 to 1, it's very clear that our x, because if we talk about our parabolic curve, the value for our a and b is where our x is actually in between your x sub 1 and x sub 2 for equations in the form of y is equal to x squared. And since your x sub 1 is 0 and your x sub 2 is actually 1, that would be for your a and b components as well. Now, for your x of t, if we're talking about a parabolic curve, your x of t is just equal to your t, and your y of t is equal to your f of t. And then your f of t in this case is actually equivalent to your curve here, x squared, identified here. So that means that's your x squared. Instead of x, it will become t squared because that is your function. Okay? Now, with that in mind, our first derivative for x of t is 1, derivative of t. As for our y prime of t, its derivative of that, which is actually equivalent to 2t. Okay? So now all of these are identified. We have our a and b. We have these components here for our parameters or parameterization, and we have the first derivatives as well. So we can now plug them in this given item. So this is now the integral of a again 0, so 0 to 1 of your p. Take note that even if we have here x and y, our p originally is just x. If in case we have another example later on, let's say minus 2y, so we're going to have this minus twice of that because that's for our y of t. But since we have here only x, so we will be using x of t, which is just t identified here. Okay? So we have only t times the derivative of x of t, which is 1, identified here. Next, plus your q is only y. So y stands for this, for the parameter. So you have t squared times the derivative of your y is 2t. This is under dt here. Now, to continue, of course, 0 to 1, you only have your t plus, if I'm correct, 2t cubed dt. Now for this, we simply need to apply the rules or properties of integration. So you have here the integral of t dt plus twice the integral of t cubed dt from 0 to 1. The linearity property is applied here. Now, let's attack them separately. The integral of t dt is obviously t squared over 2. That's plus 1 in the exponent, and the exponent will be your denominator. Similarly, the integral of t cubed dt is actually t to the power of 4 over 4. So n plus 1 over n plus 1, or t to the power of n plus 1 all over n plus 1. So you have here the integral. Okay, no longer integral. You have here t squared over 2 from 0 to 1 plus twice t to the power of 4 over 4, 0 to 1 as well. Okay? Take note, you can still simplify this. So let's do that. Okay, let's try to simplify that before substituting the boundaries. So you have t squared over 2 for 0 and 1 plus t to the power of 4 over 2, 0 to 1. So let's break them now. You have 1 squared over 2 minus 0 squared over 2 plus 1 to the power of 4 over 2 minus 0 power of 4 over 2. This will give us 1/2 minus 0 plus 1/2 minus 0. So 1/2 plus 1/2 is equal to 1. This is the real line integral, or the value of the integral of the given expression x dx plus y dy along the parabolic curve y is equal to x squared from 0, 0 to 1, 1, identifying the parameters used and all the details necessary that will allow us to simplify the final answer to be again 1. Thank you very much for watching.